Yes, I mean, big data has a big impact in our business because in the end, big data needs to be transferred from one side to the other side. It needs to be collected and passed on to the right audience. That means there's an awful lot of different networks that come into play. Of course, there's satellites, which plays a big role into processing data, collecting data and pushing it out to the audiences. But also there's a lot of core networks that need to be connected together to transport all that content from one to the other. So we focus big time right now in connecting different types of networks at a global scale, because networks do not stand on their own anymore. We have to connect those networks together, whether it's fiber-based networks, MPLS technology or SDH technology, whether it's satellite technology, data connections and so forth, point-to-point, point-to-multipoint. Connections may be temporary, connections may be permanent, connections may be for live streaming data, video and media, but connections may also have to be set up for large file transfers. So we have to connect all these networks together in an intelligent manner, because the big amounts of data require careful capacity planning of all that scarce capacity in those networks. So we focus a lot on being able to connect networks, setting up the connectivity across technologies. We call that across multiple domains, but also to manage capacity at the right time for the right applications. So it has a big impact for us. There's a lot of standardization going on more in the telco environment. There's standards like ONAP, there's the Metro Ethernet Forum, etc. A lot of activities going on to really make it an open standard to connect all those networks together. Of course, these standards are still evolving. They're driven by large telco operators. And I think we can learn a lot of those efforts to also tie together the smaller, traditional smaller networks, like satellite networks, in an open manner, in a multi-tenant manner, so that everybody can book services on everybody's network. We're really going to a shared mode where networks are not isolated anymore. On the contrary, networks are being opened up for other parties to provision and monitor their services across multiple of those network domains. Data analytics plays a big role because we focus on the operational side of the networks, which is a big challenge. Everything's coming IP, different network technologies coming together, so it's becoming very complicated, and it's all at a global scale. So if things start to go wrong, operators are faced with an awful lot of metrics and dashboards, which is very hard to identify what's really going on. Is the plant running healthy? Is it not running healthy? Is it about to break down? It's almost impossible to still have a look at that. The second thing that comes into play in the modern networks is the effective sharing of resources. The sharing of resources is done by what is called often virtualization. So you have one common platform, you can run the software application that you need at that moment in time. Do you need to have an endpoint that is processing video? You just load the video function on it. Do you have an endpoint that really has to process a lot of data? Then you can load a VPN or another function on that. So that increases the complexity of managing those networks big time. So today, if you look at and talk to operators, they get so much dashboards, they got so much counters and information from all kinds of technology that it's virtually impossible to manage the plant in an effective manner. So from our perspective, we try to help there. We create an operational environment which we call now augmented environment, where artificial intelligence on our platform in real time will help filter information for the customer, but also aggregate things together. Okay? For instance, we can forecast things to happen in a network. Because we learn what has happened in the past, we can forecast in an intelligent manner. We can forecast and predict if there's alarm conditions going to happen tomorrow, next week. We have some real examples on the booth here. We call that predictive alarming. Yeah? So we have that capability already available as well. We have a very nice thing now which is called incident detection. So if something goes wrong, operators are overflooded with 100,000 alarms, even 1.2 million alarms a day sometimes, if I talk to operators. All kinds of alarms happening in the network. There's no way to find out what is relevant, what is not relevant. So what we have here is automatic incident detection. So automatically, without learning, without setting up rules in data miner will collect hundreds of alarms together and just pinpoint to, look, there is an incident and that's probably the root cause out of it. We have things like adaptive dashboards, where data miner, instead of creating and visualizing fixed dashboards, which show information that the operator expects may go wrong, because that's the essence of a data miner. You don't look at something that is going wrong, you expect to see things there that may go wrong eventually. Well, operators can set up hundreds of those dashboards, which most of the time tell you nothing. So we now have something here at the booth that we call an automatic dashboard generation. So based on the conditions of the network as it is today, the operator will see the most relevant dashboard automatically on the screen. So we do a lot of AI, deep learning type of bits and pieces in the operations, and the entire thing together really augments the operational environment, because it's way too complex nowadays for a human brain to manage those complex networks.